Hello, this is Mr. Rasmussen with Algebra 1, Lesson 91. We have multiplicative property of inequality, and the second part is on spheres. All right, in this first part here, we are reminded that the same rules that we use for solving an equation also work for inequalities. We can add or subtract the same amount to both sides. Doesn't change the validity. We can multiply to both sides or divide to both sides the same amount, and it doesn't change it. So we use that same rule here and then graph those. So let's look at example 1. It gives me negative x is larger or equal to 2. Well, I got to get x by itself, so I'm going to divide both sides by a negative 1. Remember, when you do that, you have to flip the sign in the middle there, so I actually get x is less than or equal to negative 2. And then I will graph that. So if I put negative 2 on my line there, I'm going to put a closed circle because it is equal to it. And then x is anything less, so it's a line going to the left because it includes all reals as the domain. All right, the graphing part isn't new. It's just getting the x value by itself first. Okay, let's look at example 2 here. I need to get x by itself, so I get a 4 on this side. Let's subtract a 4 from both sides, and that's going to give me negative x less than or equal to 2. Then I need to divide both sides by a negative 1 to be able to get my x by itself, so I'm going to get x. Remember, that flips, so it goes the other way now, and once again, negative 2. So in this case, it turns out to be this, well, just a little different. Let's put my negative 2 in there. What is my domain? My domain is actually integers. So I'm going to have a closed circle on negative 2. X is anything larger, so it's going this way. I'll stick my arrow there. Then I'll go negative 1, closed circle. It doesn't include all the fractional numbers in between there. So 0, closed circle, 1, closed circle, and you can see that there in the book. All right, example number 3. Let's subtract 4 from both sides as we reduce this here. So then I have negative 3x is less than or equal to 9. Then I'm going to divide both sides by negative 3. Remember, my sign's got to flip. Common mistake to forget that. So x is anything larger than or equal to 9 divided by negative 3 is now a negative 3. So let's graph that. Let's put a negative 3 on my graph there. It is equal to it, so put a closed circle. X is anything larger than. My domain is all real numbers, so it's a solid line and going to the right. All right, I think those are pretty straightforward. You should do well with those. Second part of the lesson has to do with spheres. So the three-dimensional objects, such as like a basketball or a volleyball. And our first equation here tells us how to find the volume of it, the whole substance of the whole inside. They show you there how they derive that from the area of the base and the height, and then it takes up 2/3 of the inside of the cylinder, and so they show you how to do that, but you can just grab the equation here that's finished. All right, so in the first example, they tell us what is the volume of a sphere whose radius is 3 centimeters. So I put that in there. Here's my pi. Then I put my 3 in right there. So that way, if I multiply it out, I'd have 4 times 3. If I move it around a little bit, 3 times 3 times 3 is 27, right? And then 3.14. And then my 27 divided by 3 is 9, right? So if I divide my 3 here, then I get 4 times, I'll put it like that, times 9 times 3.14. And when I multiply all of that out, I get 113.04. And then my unit was centimeters, and its volume, so it's centimeters cubed. Okay, How do you find the surface area? If you were just to wrap or paint the outside of the ball, that equation is 4 times pi times the radius squared. So in our example here, I got 3.14 as my pi, and then it tells me the radius is 4 meters. So I stick my 4 in there. So that would be 4 times 4, which is 16, times another 4, which is 64, times 3.14, and as I multiply all that out, I get my 290.96 meters squared, because once again, it's area. All right, those ones are pretty straightforward, just plugging in the radius and then using your calculator to multiply it out correctly. All right, let's work through the practice problems. And you can, if you'd like to, check your answers. All right, practice problem A. And practice problem A, we are given a negative x is larger than or equal to 5. My domain is all reals. So I'm going to multiply both sides by a -1. That gives me x is anything less than or equal to 5. And to graph that, I'll put my 5 right there. It is equal to it. So I'll put a solid line there. X is anything less, so a solid line to the left because it's all reals. Pretty straightforward. All right, practice problem B. I have 2 minus x, throw a little different here, is not equal to 1. And my domain is integers. All right, so once again, let's write what it is equal to and work with that. So I'm going to have 2 minus x is anything larger than 1, but not equal to, because remember that's part of the negation. All right, let's get it by itself. Let's subtract the 2 from both sides. Gives me negative x is anything larger than -1. And now divide both sides by -1. That gives me x. Remember, it flips. Is -1 divided by -1 is just 1. All right, so if I'm going to graph that, I'm going to get, well, we'll start with a 1 here. And going to do, well, it's just integers. So you could do an open circle, but it doesn't really make a whole lot of sense because it doesn't include that. It's just integers. So which way am I going? Well, x is anything smaller than, so I'm going to my left. So I'm going to do a closed circle on 0, a closed circle on -1, a closed circle on -2, and an arrow to show that's going to keep going in that direction. All right, practice problem C. Once again, this is an open circle. Does not include that one. Let's just take it out altogether. It's gone. There we go. All right, practice problem C. -3x plus 5 is larger than 1. My domain is all integers. There we go. So, all right, let's subtract. Let's subtract 5 from both sides. Try to get that away from the x. So I got -3x. That cancels, is larger than, and -4. Then I'm going to divide both sides by -3. So x is anything, remember that flips, less than a 4/3. Oh, they're giving me a fraction. This is different. What do I do with that? Well, looking at my domain is just integers. So 4/3 being a fraction, if we make that a mixed number, it's the same as 1 1/3. Does it include that number? It does not, because that is not a whole number. X is anything smaller than that. So if I look at this, the next smallest whole number is going to be a 1, because I gotta go smaller. The next largest Next largest whole number would be 2, but I'm going smaller because x is smaller. So I do a closed circle there, and then it's anything smaller, so I'm heading that direction here. 0 with a closed circle, -1 with a closed circle, and a nice arrow to show that it continues in that direction to the left. Okay, practice problem D. Find the volume of a sphere whose radius is 4 inches. Well, once again, 3/4 times pi radius cubed is my equation for volume. So I'm going to have 4 thirds times 3.14, and then it tells me my radius is 4 inches, so that is cubed there. All right, so if I put that in there, 4 times 4 times 4 is 64. And 64 times another 4 divided by 3. Use my calculator for this. Times 64 times 4 divided by 3 equals, looks like we get 85.3 repeating. So then I'm going to multiply that by my 3.14, and looks like my answer is 267.9, and then I'll round it to 5, and then it was giving me in inches cubed. So there's my volume for practice problem D. All right, practice problem E, find the surface area. 4 times pi times radius squared is my equation. It tells me that my radius is 5 feet. So I'm going to do 4 times 3.14 times 5 squared. My 5 squared is 25 times 4 is 100. So move my decimal place. Actually, don't need my calculator for that one. That is 314 cubic feet. Answer. Okay, hope that goes well for you. If you have any questions, please feel free to contact me, and have a great day.